Here we're looking at section 1.4. We're continuing looking at some just general geometry things. And our essential question for today is, how can you find the perimeter and area of a polygon in a coordinate plane? First, we want to look at what a polygon actually is, and that's our first learning target, is actually classifying those polygons. Then we're going to work on finding the perimeters and areas of polygons in the coordinate plane. And remember, our coordinate plane is that grid where we can graph different points. So that will also come in very handy here. So the first thing is this first core concept of polygon. So remember, when we're taking notes, we never want to just copy everything, because this is just too many words. So a polygon is a closed figure formed by 3 or more sides, right? We always have vertices, so a vertex is where those sides meet. So I name a polygon by listing the vertices in consecutive order. So I start at one corner and I go around in a circle. And it doesn't matter which direction. I just have to pick a direction and go. So now I have to classify each polygon by the number of sides and tell whether it's convex or concave. So this first one, I always want to count the sides. So I have 4 sides. So this is a quadrilateral. And I see that it has this part, so it goes in a little bit, so it's a concave polygon. So now let's look at B. So first I want to count the sides. And sometimes it's easier to just kind of tick them off. So I've got 1, 2, 3, 4, 5, and 6. So I have 6 sides, so this is a hexagon. And I see that all of my angles all of my sides go out. So this is going to be my convex polygon. Okay. So now here are a couple to try. First, figure out what kind of polygon it is. How many sides am I looking at? That's the big important piece that we need to get from this. Okay. So now I want to find the perimeter. So I see I have triangle ABC with vertices at -2, 3, 3, -3, and -2, -3. So I'm a picture person, so I always have to draw just a general sketch of what I'm looking at, right? And it doesn't have to be exact, I just have to give myself kind of an idea. So I see that my first point is at -2, 3, so there's A. Point B is at 3, -3, B's down here. And then C is at -2, -3. So there's C. And I can draw my triangle and see what I need. So here I'm asked to find the perimeter. So to find the perimeter of a triangle, I know I need to find the lengths of all 3 sides, and then I add them together. So let's see how we kind of do that. So first I always draw it. To find side length AB, that's going to be my tough one, right? Because that one's going at a weird angle. So here is where I use the distance formula, or I notice that this is a right triangle, so I can use Pythagorean theorem for that. So I know that the distance from C to A, right? So I've got this is up at 3, and this is at -3, so this is a distance of 6. Here I have a distance of 5. So now I can use this information to help me find this third side, right? Using Pythagorean theorem, I have A squared plus B squared equals C squared. And that's exactly what we're doing down here using the distance formula. We just can use either one. They are the same thing, in fact. So if you rather draw triangles and use Pythagorean theorem, you can do that. If you'd rather use the distance formula, use that. It's the same thing. So I end up with 61 equals C squared. So C is the square root of 61. This is not a nice one that we know, so I can go ahead, because I'm finding the perimeter, and use my calculator. If ever I'm asked for exact distance, this would be my exact distance. When you see the word exact, do not use a decimal. But for here, we're just finding the perimeter, so I want to go ahead and use my calculator and see that I have approximately 7.81. Well, we've already found the lengths of those other sides up above when we were using the Pythagorean theorem, so I have those lengths. So to find the perimeter, I just add all of those together, and I end up that my perimeter is 18.81 units. So now here are a few for you to try. Definitely always start by drawing your figure so you know exactly what you're looking at and where it's at. So now let's find the area. So again, I'm looking at triangle, DEF, with vertices at 1, 3, 4, -3, and -4, -3. So again, I have to draw myself a quick sketch so I can see what I'm looking at. So D is at 1, 3. E is at 4, -3. This was D, and this is E. And F is at -4, -3. Okay, so I see here is my triangle. So now I have to find the area. And just to refresh, to find the area of a triangle, it's 1/2 times the base times the height. And I know that the height always has to be at a right angle. Okay. So first I drew my picture, which again looked something just like that. So now I'm going to have to find the lengths of my height and my base. So I can do that literally just by counting, because I'm going to use this flap side that goes straight across at no angle as my base, just to make life easier, because then I don't have to use the distance formula. I can literally just count how far it is. So we're going to use that base is FE. So I can use my ruler postulate, and it doesn't matter if you know the names of all of these, just know that I count how far it is. So I find that that length is 8 units, and then I would need to find the height. Okay, so to find the height, I know I have to go at a perpendicular, a 90 degree, from this base to my other point, which is right there. So I know I have to make this 90-degree angle. So again, my line segment here from D to my FE segment follows along one of my lines. So again, I can just count the pieces and not have to actually use the Pythagorean theorem or the distance formula. So I see that my height is 6 units. So now I just substitute that into my area formula, which is 1/2 base times height, and simplify and multiply. So I see that the area of that triangle is 24 square units. So here are a few more to look at. Give them a shot, see what you can do. So we're going to look at kind of a real world problem here. So we're building a shed in your backyard. This diagram shows the 4 vertices of the shed. Each unit is 1 foot. Find the area of the floor shed. Well, first thing I have to think of is, how do I find the area of a rectangle? And this is a rectangle, so I know that the area equals length times width. So we'll call this up here length. Let me get a different color. We'll call this length, and we'll call this width. It doesn't matter as long as you pick one. So let's count, because again, I see I'm at nice right angles here, and I don't have to use Pythagorean theorem or distance formula, so I can just count. So I see that my length is 1, 2, 3, 4, 5, 6 units. So I'm going to substitute that in. And the width is 1, 2, 3, 4, 5 units. So I know to find the area, I just multiply those together. So I end up with the area is 30, and I'm told my distance measurements here is feet. So I have 30 feet squared. And when I'm dealing with area, I always want to use that exponent of a square, because that's what I'm really looking at. So now here's one for you to try. Try and follow along just what we did there in that last example. So now we're going to look back at our learning targets. First, we classified polygons, and to do that classification, we always want to see how many sides does that polygon have. It'll come into play a little bit later about concave or convex, but the biggest thing is just knowing what they're called and how many sides they all have. Then I found perimeters and areas using the coordinate plane. We always have to draw. That is always going to be step one, big key thing here that I have to see in your notes, is to draw your simple sketch before you can find the perimeter or area. We always have to draw a picture first, and that will help lead us here. Okay, so now that we've worked on these learning targets, go ahead and work on your homework for this section.